We will now look at additional operations on atomic variables in addition to the plus plus, minus minus and compound assignment operator. For these operators it is always sequential consistency that is used, but for the primitives that we will see, it is optional to use another memory consistency model. That is, we can specify that we should not use sequential consistency. To be concrete, if we want to read a variable, then we can use, well, either we can read it as it is, taking the contents, or we can use atomic load and take the address of the variable, and this will be operation using sequential consistency. We can be explicit and say which memory consistency model or memory order that we want to use for this operation. So here we say that it's relaxed, so it will be unordered with respect to other data operations, but not previous acquire or a future release, of course. So which memory orders can we specify? Relaxed, that is a normal data operation, unordered, and acquire is using the acquire operation from release consistency, and release operation, acquire release, that would be using weak ordering, and sequential consistency. Consume, I will explain later. It is similar to acquire but more flexible, well, less strict. We will come to that. It's inspired from the Linux kernel. Okay, so let's continue. So now if we look at this code, and let's take a quiz. Can the values of x and y both become 42? So thread 1 will do this. It will read B, and then it will write A to A. Okay, and thread 2, it will read A and then read it into Y, and it will write 42 into B. So can both x and y get the value 42? If you want, take a pause. Otherwise I will continue. Well, I will continue anyway. So the answer is yes. And why can it be so? Well, since we use memory order relaxed, and a thread can reorder these operations. Well, not thread 1 cannot reorder them because well, let's look at it. It reads x and then it uses x. So here is a data dependence on x. So it would be impossible to change the order for these two. But thread 2, these two operations are unrelated, so they can be reordered. Okay, so let's say that thread 2 starts with writing 42 to B, and then thread 1 reads B and saves the value 42 in A, and then thread 2 reads A and into Y, so both x and y become 42. Okay, so now let's look at an atomic exchange operation. What it does is to change the value of an atomic variable and the return value of this is the previous value of the atomic variable. It's interesting to look at the type of this function. So the return type C, that corresponds to the non-atomic type, and A is the atomic type. And actually the standard uses volatile here. That's not so pretty, but it is how it is written. And what it basically tells the compiler is that it shouldn't try to optimize what this pointer points at. Okay, so here is the pointer to the atomic variable, and here is the value that we want to write to it, and here is the memory order that we should use. Okay, and we can return the previous value. So if we have this node, we can have 3 variables involved. Now we come to, well, this is also a lack of imagination, so I use this node, but as I mentioned previously, well, you can of course, but it is not intended as a hint that it would be better to use atomic nodes from the labs. Okay, it's just to introduce something familiar. Okay. You will find atomic variables useful, but perhaps not exactly like this. Okay. So, if we want to use this, you may notice something odd, namely that if this struct is small, you can compile it with GCC or Clang as it is, and we suppose it in this file. But if this struct is big, then you need to use this -L atomic. And now you may wonder why. And the reason is that for a small struct, the compiler inlines this function. I mean, it knows what it does and just produces the machine instructions directly without calling this function. But if the struct is big, then it's inefficient to inline the code, so instead it calls the function, and therefore it needs the library where this function is located. Usually you don't have to specify that you want something from the standard library. For instance, if you want to use printf or malloc, you don't need to, well, you need to include the header file, but you don't have to write which library it is on the command line. But for math functions you need to do that, and then it is -lm, and for atomic, I mean the functions relating to atomic variables, you use -L atomic. Okay, so should we use that? Yes, it's better, since if somebody changes the struct later and it is not inlined, then it would break the script to compile the program. So it's better to use it at once.